or anything that you want to attack. It's going to spread to the rest of your body.
We've made it through my first line of defense, the skin. I am now in my second line of defense. And the macrophages are trying to kill the pathogen. So they're mounting an attack. And they're readily available. If they can't kill it, they're going to help start my third line of defense. Now, fever is important. Comes with a viral or bacterial infection, stimulates lymphocytes to proliferate. They can secrete interleukins. Interleukins help to raise the body temperature. If we raise the body temperature, we stimulate the lymphocytes, which are going to proliferate, creating the interleukin, which will raise the, do you see my point? Okay, it's not always a good thing to try to stop a fever. When should you try to stop it? When it gets too high. What's too high? Roughly about 100 to 101. Okay? Other than that, leave it alone. Okay? Just drink plenty of fluids. Because the elevated body temperature inhibits microbial growth, increases the phagocytes. Don't try to stop them. Let them do their job. Oh my God. It's like people get a temperature of 1 degree and they're alternating Tylenol and Motrin. And I'm just like, stop! Sit down, drink some fluids, get a blanket, and just be still. You know, keep a check on it. Those were my second line of defenses. So now, if that pathogen has made it past the first line, the second line, meaning my little macrophages who tried to fight it off, okay, if they lose the battle and whatever the pathogen is increases in number, my little macrophage is going to say, hey, man, I'm done. I need some help. And we're now going to move into my third line of defense. Meaning, we have to get specific. Very specific. The third line is immunity. Something we build up. Okay? It's resistance to a particular pathogen or to toxins or to a metabolic byproduct. It's based on the ability of the body to recognize it as a non-self cell. Antigens are going to be the molecules that get the immune response. So, yes, that's the goal of a vaccine, to introduce what they, I guess, term like the dead virus, get your body to recognize it and build up the immunity. So let's say pathogen attempts to get into the body. It makes it through my first line of defense. Pathogen gets into the body. The next thing that's going to happen, my second line of defense is going to try to control it. However, if my second line of defense cannot control the reaction, or cannot control the pathogen, I should say, I'm going to have to count on my third line of defense. My third line of defense, we either have a cellular response or a humoral response. And I don't mean ha-ha, okay? What does humor? H-U-M-O-R, and it's usually H-U-M-O-U-R, depending on how you look at it. What is humor? It's the fluid, usually blood. It was referred to as humors in early times. So, my third line of defense, it's either going to be something that deals with a cell specifically, or something that we have to use the blood for, okay? The product, the pathogen, the whatever the case might be, the part that is going to get the response is an antigen. An antigen can be a protein, a sugar, a glycoprotein, which is found on the membrane of cells, or glycolipid, once again, membrane of a cell. Do you guys remember that in the plasma membrane? The most effective ones are usually large and complex. So here's what happens. When that pathogen tries to invade the body, well, they might be small, so they are termed a hapten. But when something tries to invade the body, do we just get one? We might just get one, but what is it going to do? It's going to multiply. So if you can get a bunch of them together and they get big, they can stimulate this third line of defense. So if we begin to stimulate that third line of defense, that means we have to get specific. Now, that means my white blood cells, my lymphocytes, have got to be activated. All right? In other words, the macrophages could not control the pathogen. So, we're going to have to get production of more of these white cells. Now, our lymphocytes, for the T cells, like I said, to the thymus, get exposed to the thymosin, go to the lymph node. But there's another lymphocyte, the B cell. The B cell, this one, humor, because B cells are from the bone marrow and they're in the blood. Their job, help the T cells. So the T cells, they are a cell, so we get a cell response. We have to activate these lymphocytes, the T cells, the B cells. To activate the T cell, which is hopefully sitting in the lymph node, okay? Or if we got to get a new one started, we can get to it. But to activate it, we've got to have something present that pathogen to it. So here's my T cell that's mature, and it's waiting. Because it's like, oh man, please let today be my day. You know, it's a cell that just wants to go to work. But we got to activate it. So at this point, my macrophages have not been able to control that pathogen. Is everybody with me? Now my macrophages do this number to a pathogen. Eat it. Meaning they take it in, they expose it to chemicals that should break it up, all right, and hopefully take care of it. But if they get overwhelmed, they need some help. So that macrophage will take a piece of that pathogen and push it to the cell's membrane. And then, guess what? That macrophage, with the piece of the pathogen on it, okay? Think of the macrophage as having a piece of the pathogen on it, all right? It is now an antigen-presenting cell, all right? And guess what? Here's my T cell over here. And it's going to go, I need some help. And the T cell is going to go, cool, it's my day. So the macrophage becomes an antigen-presenting cell and takes it to the T cell that's waiting. Huh? The macrophage becomes the antigen-presenting cell. Do it, Cass? Well, it'll take it to the closest T cell it can get to. So wherever that lymph node might be, that's where it's going to travel. Is everybody with me?
So the macrophages are the macrophages for
Well, the macrophages were the ones that could be the first cells to get there.
Okay.
So they're like the first cells to get called up. And what they do is, like, think about the cutting of the finger. They're trying to eat anything that was invading at that point. But let's say something got past that point, macrophages couldn't handle it, and so they'll put a piece of that pathogen on its cell and take it to the T cell. So, T cells can synthesize and secrete polypeptides, amino acids, a string of them, okay? And they're called cytokines. The T cells can either be a helper T cell, a cytotoxic cell killing, all right, or a memory T cell. Because if a T cell gets activated and if it has to go and fight a pathogen, it's going to create a memory of it. And then that memory cell goes back to a lymph node somewhere and just sits and waits. And some of those memory cells last a lifetime. So if you're ever exposed to that pathogen again, you never get sick.
Is that like you get the flu shot?
Yes. Yeah, they have 3 strains that are in that flu shot. And if you get sick with the flu, you got exposed to a strain that you've never been exposed to before. It's kind of cool.
So is the flu shot, like, what is it? Does that help activate the T cell?
Yeah, what that'll do is when you get the shot, It will send your body through this entire T cell process, and they'll create a memory, and the memory cells will go and dock in a lymph node somewhere, waiting for exposure. So, the types of cytokines that can get produced, we have something called colony-stimulating factors, interferons, interleukins, tumor necrosis. Their job, do something for production of a particular type of fighting cell. Maybe something to give us more lymphocytes, T cells, B cells. Maybe something that will work against viruses. Maybe something that will help cells proliferate. Maybe something that will affect cancer. So these T cells, this is what they produce. Now the B cells, with the B cells, what we're going to see is their job, they can be activated when the antigen fits the shape of a receptor. So, that pathogen that's trying to invade, that creates the antigen, if it can fit into the receptor on that B cell, that B cell will get activated.
How would it be able to fit onto the antigen if it was never exposed? So
It would have to be exposure, and once again, we'd have to build. Yeah. And if we haven't been exposed before, it will go through the process of developing the cell. Yeah. So, do you remember the one that was the helper T cell? Helper T cells can help the bees. They can release a cytokine that will say, hey, B cells, we need you. Some of the B cells make a memory, not all of them. And some of the B cells, okay, will be long-lasting memory. Some of them may only be short-term memory. Now, when they get activated and they begin to increase in number, they can differentiate into plasma cells. Those secrete, have you heard of antibodies or immunoglobulins? They're very important to our defense system. There's a lot of them, okay? There's a lot of antibodies that we have and a lot of IGs that we have. The immunoglobulins, from the time of birth until we die, okay? This is just showing how those B cells would get activated. The helper T cells kind of shoving them, kind of saying, okay, do your job, do your job. And then as they proliferate and increase in number, create their products, some of them will become a memory cell. Some of them can go on to be fighting whatever's trying to invade. Just a little bit larger view. Now, when the B cells proliferate, we're going to find some of them become a memory. Just like the T cells, they will go and sit and wait. Once they're exposed, again, they may or may not be ready. But if they're ready, you're not going to get sick again from that same pathogen that you've already been exposed to. So, antibodies with the B cells. We got to have something that becomes the antigen, something that becomes the problem that we're trying to deal with.